Thank you very much. My name is Mark Handcock. I'm a professor of statistics here at UCLA, and I'd like to welcome you here to our night to the In the World seminar. It's a seminar developed by the advisory board for the data theory program here at UCLA. I wanted to start just by describing to people who are new what is data theory. And the idea with it goes back to the more basic question of what is data science. Data science is the science of how to learn from data. And many people here are directly involved in it, either through the program or through their work areas as well. Now, as you know, there's an enormous amount of interest in data science, both at the university level and in industry. And most of the teaching programs related to data science focus on the methods of data modeling and develop in the students various tools and techniques that they can use as working data scientists. The idea of the data theory program here is different. What we want to do is focus on the underlying principles and foundational ideas that underlie data science. And so the idea here is that data theory is the mathematical and statistical foundation of data science. So it's a joint effort between the Department of Mathematics and the Department of Statistics and Data Science to focus on these core principles. And that is what we're really trying to do. What we're here for tonight is the second of a three-part series of In the World seminars that address different aspects of data-driven organizations. And the topic tonight is, as written up here, knowledge graphs in data science. We have two panelists here tonight. Unfortunately, Wei Wang, who is going to be the moderator, cannot attend because she is not well. She was the Leonard Kinrock Chair and Professor in Computer Science. So you'll need to put up with me being the moderator, which hopefully is not too much of a disappointment. Without too much ado, I'd like to introduce our two panelists here, Xia Li, and also, I'm going to pronounce this very badly, very bad, Houshmand Shirani-Mehr. Is that acceptable? Yeah. Great. So if you'd like, would you like to briefly introduce yourself?
Yeah, sure, no problem. Hi, everyone. I am Xia, and I am just like you, everybody here. I graduated from UCLA last October, and I graduated from the math department with an applied math PhD. And I specialized in stochastic processes, and I also did a project in knowledge graph, also optimization. So I was jointly advised by two advisors. One is Deanna Needell. She is the chair of the data theory program, and another advisor of me is Andrea Bertozzi. You might know them, and they are all like very great women mathematicians, in my opinion. And I'm fairly new to industry because I graduated last year, and after that, I joined Microsoft as a data scientist. I work mostly on the Azure side of Microsoft stuff. So that's like a cloud computing, just like AWS, if you're familiar with. So in our organization, there's a lot of applications using knowledge graph, and we will talk through it. And if in the end people are interested, you can totally ask more questions about that. I think knowledge graph is a very useful data model. And during my PhD, I did this project called, it's basically a case study that used knowledge graph to infer the killer of a murder in a story. I think it's called Veronica Mars, if anyone is familiar with that show. So basically, we create a knowledge graph from the script of the show, and based on the the people and their relationships and all kinds of clues we included in that knowledge graph, we are able to use I think it's a graph neural network model to infer who in the end has the most probability to kill I think it's the Lily, the girl Lily. So it was a very fun project, but that's like a starting point where I started to, know more about knowledge graph and what we can do with it and how powerful it could be. And as I joined Microsoft, right now I already know a lot of teams are working on it, different projects, and those are very interesting as well. And I'm excited to be here to share with all of you guys. And thank you.
Hey everyone, my name is Houshmand. I'm an applied science manager at Snap. Very happy to be here. So I've been in this role for about 6-7 months now. Before that, I was leading an ML team, the startup called Bolt, for about 2 years. Before that, I was at Meta in their core data science team, and before that, I was at Snap again for about 4 years. And before that, I was in grad school doing my PhD. So my PhD was in management science and engineering at Stanford. It was mostly about my research was mostly about applied statistics and machine learning, political science, social science problems. In terms of my interactions with knowledge graph, the team that I'm leading at Snap right now is responsible for conversion attribution, which I can talk more if you are interested in. But it's effectively so it's effectively about how do we connect purchases that happens on the internet to users on the platform. And one thing that we use really strongly for that is an identity graph, which is closely related to a knowledge graph. So effectively you have nodes related to entities and the relationships as edges, email addresses, phone numbers, cookies on the browser, all these sort of things going to be nodes. And then you have to traverse this graph to figure out who is the most likely person to correspond to this conversion. Yeah.
Great.
It's cool.
That's very good. That's very good for the introduction. So let's now go to the questions. First question. When did knowledge graphs become important in your organization rather than databases? So this is a question related to, given the organizations you're in now, where did the transition from traditional flat databases, if you will, to more knowledge graph structures? We'd like to have a shot at that.
I can start. So I actually saw these questions, so I cheated a little bit. I looked into the documents of Snap, and I see the first time that we tried to do something with knowledge graphs was when we wanted to build our ad stack about in 2016, I would say. So what we wanted to do is how do we help advertisers target different audiences? So you might have, they might have specific preferences, but how do this preference map to stuff that we show to users? So effectively you have to map content to preferences, map users to preferences. So this was something that was evaluated at the time. We ended up not using a knowledge graph for something like that. On our side, on the identity resolution and conversion attribution, we started working on identity graph, I think in 2018, around 2019, to have our own solution for matching conversions to impressions, and then use that as labels for ad ranking, all of the ad systems that we have. Starting this year, we are experimenting with some sort of knowledge graph databases. So traditionally, we're using traditional databases to handle that. Now we are experimenting with GraphDBs and knowledge graph databases like Neo4j. But yeah, we haven't had anything in production yet. So that's the summary.
Yeah, so I also cheated a little bit because I cannot recall like the actual year when Microsoft started to do using knowledge graph. But basically, I think the first company who started to adopt a knowledge graph is Google search. So they transitioned from like a keyword search to like using a knowledge graph search. So that largely increased the efficiency of the search and the accuracy of the search. And that's around the year of 2000, either 2012 or 2015. But I think shortly, Microsoft Bing started to adopt the same technology, the knowledge graph as well. So it's kind of like the standard now. Apart from using knowledge graph for searching, Microsoft is also building its knowledge graph for academic. So as we know, like in academia, there's like this network going on. Like, oh, I cite your paper, and maybe you cite mine, and all this complicated knowledge about like citations, publications, journal, and conferences. So that's something I think also around 2015, Microsoft started to build that as well. And I think the following few years, there are more applications starting happening in Microsoft because people know that this is great for search. It just very efficient, and they started to build build knowledge graph based search in like other product, like I think it's office, like also like Teams. When you connect with people, like there's people's number, that kind of more like a social network thing, but it's still using like the knowledge graph model. And yeah, I think that's kind of like the history of Microsoft adoption to knowledge graph.
Great, good. Move on to the next question. What is the most important business process that knowledge graphs improves compared to traditional databases?
So I'm fairly new to knowledge graph. I'm just answering based on my experiences and also my communication with other teams. I think knowledge graph improves in terms of search efficiency and accuracy. That's like the big part. And so because knowledge graph, it can contains more like complicated like relation compared to a traditional like relational database. Like you can have different attributes and using the edge to represent those relations. So the search itself, it's searching on that graph structure, but like the amount of information you can incorporate it in it. For example, when you just like searching for maybe like a place, you're just looking for a place, and then like usually on the website you will see, okay, here's some flight information of that place, or here's some restaurant recommendations on that place. So those are all like kind of based on the knowledge graph, because this place is an entity that you're searching, and then the algorithm is kind of providing the information of the nodes or the entities that have connection with that entity, so that it makes us enrich the search much more, which kind of just in the end increase efficiency. So that's the I think that my take on this.
Yeah, so I definitely agree. Like search is a really good example. I can talk about like monetization, the monetization space, like targeting, for instance, is something that is very related, and you can use knowledge graphs effectively there. Identity resolution, again, like matching conversions to impressions, is another example where the knowledge graph is kind of different because entities are now like identifiers for the users or users. but it's still something that is very valuable. And when you want to traverse a graph with like heterogeneous types of edges, it's gonna be like a very good addition to the tech stack that you have.
Good. Next question. While it is still early, it appears that generative AI will have an enormous impact on business, education, and society. How do you think generative AI will change knowledge graphs in organizations 5 years from now?
I think this is a very interesting questions, and I certainly hear a lot of conversations within Microsoft talking about generative AI ever since we like launched the ChatGPT. So there are a lot of like aspects I can think of in this, and I believe the relation between generative AI and knowledge graph is like they will help each other. To start with, I believe that generative AI can help the construction of the knowledge graph. So currently, the construction of a knowledge graph can be a very hectic process. So one way of thinking about using generative AI is to maybe like you just feed those AI, those of the data sources you have, and then ask them to generate the entities, the attributes, the relation for you in a desired format, like Neo4j, that kind of thing. That would like definitely help a lot in like building knowledge graph. On the other side, I think knowledge graph is a good data source for generative AI to train on. Or, for example, if you want to use generative AI to to answer questions, if they can use data from instead of from like a normal data source, but using from a knowledge base, that is, I think, is a work in progress. They proved that if you use the generative AI together with a knowledge base, it increase the accuracy of the question answering procedure. And yeah, so there are other I think the search enrichment I already talked about. I mean, when you search, you can just ask like Bing Chat to search for you instead of just typing and do all of the calculation in your head. So this can all be done with generative AI and with knowledge base. So yeah, I think they will like contribute to each other's growth. It's kind of like a co-evolving kind of relationship. So
Yeah, great answer. This question is very hard to answer, to be honest. Like 5 years from now, I have no idea, to be honest. Like I remember like I was doing an internship at Facebook in 2016. I was sitting close to someone who ended up being director of our org. I didn't know at the time, so I probably overshared at the time. We were talking, and she gave me a really good advice, which stick with me. She said that don't think about 5 years from now, because 5 years from now, for all we know, we can have like contact lenses that can do all the computation. Who knows? Maybe think about like 2 years from now, the cloud is gonna go away. It becomes more clear, so you can make better predictions. So I'm not gonna talk about like 5 years from now. I'm gonna talk about 2 years from now. So I would say knowledge graphs definitely have a word model. You can say like there is a way to model the word. And if you believe that generative AI, LLMs have a word model inside too, then you can argue that at some point generative AI can substitute knowledge graphs. That being said, that eliminates the caveat of computation, because computation is going to be much harder. And it's going to assume that these LLMs become robust enough so that you can trust almost all of the inferences. And it really depends on what kind of application you use. If your application that you're using doesn't need that much robustness, maybe at some point they become the knowledge graph. But if you need the robustness at the inference time, I think most likely the outcome would be a combination of the two. Even now, like I think you mentioned, like there are ways to use generative AI for knowledge graph, like add new edges, add new entities to that we have in production. But yeah, I mean, who knows? We'll see.
Interesting. Next question. Building knowledge graphs appears to be hard. Do you have advice on constructive ways of creating an effective graph? Seems a very broad question. Steve.
So I can start. So one thing that I would say is that there are lots of open source solutions right now for building knowledge graphs. And there are companies on top of those open source solutions. So definitely you don't need to build something from scratch. Like at least like the infra is already there. In terms of the actual knowledge graph, the actual entities, it really depends on your application. For some applications, definitely it's going to be hard. For applications, it's going to be easier. But I think like focusing on the application, focusing on the use case would probably make it easier at the end of the day. Yeah.
Yeah. So I very much agree with what you were talking about, that knowledge graph is the world, basically. So I think building knowledge graph is really about building your own world and the world that could answer the question you're asking. So like you said, the application. And there are like open source stuff like that can build the foundation of your world. Like for example, we know a chair is not human, so that knowledge, some of the knowledge graph already has it. But I think most importantly is define your scope. And so when you try to construct a knowledge graph, it does not have to include the whole world to solve the question you want to ask. So, for example, if you just want to ask like, who are the most likely paper I'm gonna cite in next year, then you probably only need that kind of like a academic knowledge graph to answer that question. So the scope is very important, and if you figure out the scope and the question you're asking, then the construction of the knowledge graph just boils down to look for the data source that you want to use for your knowledge. And another aspect is that is like the data quality when you're building a knowledge graph. So that's pretty important. I don't have too much like production-wise experience, but I know that could be very hectic. So maybe you can talk more about it. But I think basically the scoping of the problem and the data sources are the two ways to focus when you want to use knowledge graph to answer certain questions. That's the foundation of using knowledge graph.
Great. Next question. Recent graduates don't always know what they want to do with their lives, and many folks change jobs. What sort of experience would you encourage students to have so that they can have flexibility in choosing or changing careers?
This is an interesting question because I also don't know what to do with my life. So in terms of folks changing jobs, I don't think that's a bad thing, to be honest. I have personally changed jobs. I started as a graphics hardware engineer, my previous life. And then I did some school in like management science, engineering, data science, and changed to data science. And now I'm mostly doing ML and things like that. Honestly, very hard to answer. I would say, I mean, usually like the answer that folks give to this sort of question is like, there's a Venn diagram, something that you're interested in, something that you're good in, and something that has value. Try to find something in the middle. So as long as you get experiences that are closer to that intersection, I think that's valuable. But yeah, don't be afraid of changing jobs. It's not that bad. I went through it. I survived. So yeah.
Yeah, this question is tough too. Like, I'm like basically a new grad too. Like, I don't know what to do with my life. I think, yeah, like trying different stuff is good. But yeah, we also need to be smart about it. In my experiences, I try not to really focus on too much about, for example, for my major, I study a lot of models. I try not to do not focus on the model themselves too much. I think what's more important is to learn the methodology. Basically, the transferable skills, like problem solving skills. So even now that I graduated, I have a PhD degree and I work at Microsoft, I feel like I wasn't using anything in my research, in my daily job. I wasn't using any of that. But what I feel like I use most is the ability of asking the right questions and then trying to finding a right scope for me to answer that question. And then it comes down to, then what data do we have for that question, and then what model we can use. So this whole thinking process, we can generally call it problem solving, but in different like areas, there might be different way of solving problems, and that's okay. So focus on most the transferable skills. And also another aspect I think is always keep learning new stuff, especially in like the data science area. I feel like everything's changing every 5 years. You don't know what will happen in the future, but like just keep learning and just keep adding more stuff in your tool belt, so that in the end, if you maybe on that journey you find something is more interesting to you, then you can switch to that that area, and with a little bit less effort. So, but in general, trying things are great. Increase your experiences, and yeah, I think that would be my answer.
Great. Right. Maybe this is a related question. What do you think are the most important technical skills we should be learning to prepare for a career in data? So focus on the technical skills rather than sort of broader skills.
So, I mean, I would imagine all of you folks are really good in theory. So I would say the way to drive value is being a builder at the end of the day. So if you can build a skill set around that you can build applications around the knowledge that you have, might be as simple as learning coding. You might go deeper, like building applications around it. I think that would be very valuable. Like that is something that helped me a lot. Like the fact that I was able to implement the methodologies that I was thinking about, experiment with them. I think that was very helpful for me, like building my career at the beginning. So I think that would be something that makes you much more valuable to any place. So yeah, try to drive value and basically try to be a builder.
Yeah, so I really echo on that because I come from a more of a theory background, even though I run simulations as well, but most of my work is like, I'm solving this problem. I'm trying to study the COVID-19 spreading with, the government's policy. How would policy influence the COVID spreading and vice versa? And then I have this nice model and do simulation of it, but it's very different, completely completely different from a product. So if you want to be in the industry, a product, you have to like think of a lot of things on different levels, like user levels, and also like engineering costs, and like this is basically building a thing that can be used by different by a lot of people. So so I actually feel like the technical skills you need. I'm sure everyone here, you have a great foundational theoretical work. I think, yeah, one thing is coding. The other thing is really think about from a user's perspective. Instead of just thinking about, I think this like model is super cool and I want to use it in this application, but actually maybe a easier model would be applicable to this problem and easier for the users to understand, for the users to use, then that's the most important thing. So yeah, I guess that's not like super technical, but it's also like technical in a way.
Yeah, so I really echo your points. Like if you try with a very sophisticated model, the next person who's gonna maintain is gonna hate you.
Yeah.
So if you don't want to be hated, try to start with like the simplest thing possible. This is always a good idea.
Great answers. That's it. That's the end of the formal questions. Applause. That's good. Now it's time we can ask questions from the audience, starting with knowledge graphs and on any topic. Let's see. Who would like to go first?
Cool. Hello, thank you for being on the panel today. So we covered a ton of stuff, and I'd like to ask you a personal question related to those topics. So we talked about graphs, right? And it's a data structure. You get to represent in a matrix. You can use linear algebra. It's wonderful. It's highly efficient for doing things like that. There's just the theory of what you can do with this data structure. We talked about databases, where you pointed out you can model this structure in Postgres. It's not, doesn't violate any fundamental laws. You can use a purpose-built tool like a Neo4j or what have you, and that's great. And that's sort of like the sysops world where you're like, well, if it's fewer than 6 traversals, your performance is going to be the same anyway. And, you know, we've got in-house expertise in this. And so there's like the theory of that. There's actually implementing the infrastructure, bringing it to the world. And then finally, there's kind of like the glue role, right? Where it's like, we talked about data modeling. Okay, these are the traversals we're doing. Let's model this so our cardinalities are such, we're not going to have a really deep traversal in this query where we have to go fast, right? There's like the practicality of it. So that's all context. The question is, of like these verticals in this space, what do you personally find the most interesting? Where are you your happiest working across these? And then in the realities of the world, where do you find yourself spending the most time, and what seems to be the thing that really consumes you for the business? Are they aligned or not? Super curious.
So that is a really good question. The thing that I honestly enjoy the most, I'm happier the most if I work on, is probably the theory part. But at the end of the day, like, I'm wiser now to know the thing that has value is the application. And the application is probably closer to what glues these two together. So if you have an application that you can come up with like very simple solution, it's always cool to have like a very sophisticated solution, like graph neural networks and things like that. I was very interested in them at some point.
Yeah.
I try to apply them, but at the end of the day, if you can get close enough value with a simpler solution, usually doesn't make sense cost-wise in terms of maintenance. Like 1 year from now, if I go back to my code and I don't understand it, it's not a good look for anyone.
Yeah.
Yeah, so that's my impression. I don't know if that answered your question, but yeah.
So you enjoy the theory, you spend most of your time in the application,
Yep.
and with all these beautiful theories and equations, counting is usually
Almost 80% of the time. Yeah. Yep. Yep.
Yeah. So I haven't really been have any hands-on experience in production yet, but also I feel like my interests will change over time. I'm like fresh out. I'm like still very into theory, proofs, that kind of stuff. But I do find the beauty of design, like what makes it's, something that you feel like when you're using it, you feel like it's just like part of you, like when you're doing some work, instead of like it builds a wall in front of you. Because, for example, like when I use iPhone and I like to drop stuff from my iPhone to my MacBook, it's just like feel like seamless. That's the design. But when I use my iPhone, I want to drop something to my Windows laptop. It's like there's a wall. I have to email myself. So that's something that I kind of slowly transitioning like into like my interest starting to grow in that area for design. So, but I haven't had any like too much experience on that. But that's something I feel like I might shift my like focus to. So yeah.
Great answers. Other questions? Don't be shy. Well, I have now a question for the audience. I know in the audience there's a number of people with great knowledge about knowledge graphs, and I wondered if they would like to make some comments about the relevance of knowledge graphs to their work. Don't be shy. Oh, question?
In your current roles, obviously, source of data becomes a really, in your current roles, source of data becomes kind of an important element of the output of the graph. So do you worry about the relationship with the other organizations that are supplying data to you? And how do you ensure that it's the old garbage in, garbage out argument, right? That you're getting good amount of data, or is that a part of what you do in your knowledge graph? Do you construct data engineering in some way to be sure you're not getting bad data?
That's a very good question. I worry about it every day. So the nature of the work that we are doing, we are actually a layer between advertisers and Snap. So our input data is actually coming from advertisers, not even a different team that we have some control over. That being said, like I think around 2 years ago, there was some sort of restructure in the team so that the team that is responsible for gathering data from the advertiser and feeding the identity graph and knowledge graph for us, this data is actually part of the same attribution team. And that helped a lot. That being said, we still have a lot of problems about outlier detection. Like if an advertiser stops sending us right amount of requests, right amounts of data, or like the distribution changes in a way that we don't understand. And then this data is going to get fed into our knowledge graph and it's going to be used by all the downstream teams. And it might like destroy the performance of an ad campaign and like reduce revenue. No one's happy about that. So definitely something that is like of the highest importance for us. And we spend a lot of time trying to make sure that it's okay. I don't think we are doing a perfect job there, but that is an area of priority. Yeah.
Follow, do you feel like you have some control over the advertisers, the kind of the framework of which they're giving it to you, so you get it in a form that's more
So
easily?
that's a very good question. We don't have a direct control, but we have levers. So for instance, there is an interface to that advertiser so that we can always alert them about, hey, like we got this data from you and it doesn't make sense. Like our outlier detection logic is to determine that there's an outlier here. please take a look. One part of that is that tomorrow, like the advertiser comes and say, hey, like why am I not getting the right performance? We can refer them to these issues. So not a lot of control, but at least we can nudge them towards doing the right thing.
So sorry, I'm dominating, but last one. On the other side of it, you said something very insightful, which is to build something. At the end of the day, you have to build something. So theory is awesome, but people, Microsoft and Snap pay your check, so you want to build something. That means you're producing. You're not just consuming, but you're producing. Can you talk about the environment that you produce to and how you add value to those upstream entities?
So I probably need some clarification on that question.
So for example, like in search, you can enrich search, right? So you could do your graph bit and then you can kind of supply that to search.
Yep.
Are there other things like that that you produce to and for that
Uh,
enrich their experience from a production perspective?
For sure. Do you want to answer? I can talk about.
Yeah, you can go ahead.
Okay, sounds good. So I can talk about like the monetization inside Snapchat because that's my area. So every ad that we show on Snapchat, it comes from a model that predicts this user is likely to interact with this ad. And that interaction is coming from an ML model that is training, does this user interact with this, does this user not interact with this? All of these labels are actually coming from our attributed conversions. So every request that comes in, every conversion, every purchase that comes in, we have to use this graph to figure out who this corresponds to with some probability, some likelihood, and then rank the users and pass it to, it becomes like a blood for all the ad tech system that we have, like optimizations that we have. And this data is used to train these sophisticated ML models, like huge models to predict, do you click or not? Now saying that doesn't make me too proud, but at the same time, like that is something that affects the bottom line of an organization that is investing in ads. So that is one area. The other area is that some of the advertisers want to understand how effective are their ad campaigns. And usually there's a lift measurement. So you have a treatment and a holdout. You show the ads to the treatment. You don't show the holdout and then compare the result of the two. And then figuring out, okay, like how many conversions, how many purchases have happened in the treatment and control and comparing them. Again, these labels are coming from the output of this knowledge graph. In targeting, like we usually build audiences for advertisers based on their conversions, previous conversions, like who have purchased anything from you in the past 6 months. Let's actually build an audience based on that, show the new ad campaign to these users. So that's another example. Yep.
How often is the data in that data set updated? That sounds like a monster thing with a lot
Yeah.
of
Yeah.
counting and references. It sounds complicated.
Yeah.
Is it batched once a day? Is it real?
No. Yeah. So again, like we are not effectively using a GraphDB sort of database right now at the moment. So we have like silo databases that are actually the underlying layer or the infra for this sort of knowledge graph. For some of these, they are coming as a stream from registration, Snapchat data, like app open data, all these sort of things. So you can think of it as like getting updated almost real time. The conversions that are coming in, purchases, things that are coming out of Snapchat, they come real time, sometimes offline based on like what are the integration. Usually they are processed in small batches. So every 20 minutes, we process all of them and then run them through this knowledge graph, do the inference. And then that is the labels and all these sort of like data that is fed into the downstream applications.
Got it. So if I turn on an ad campaign 20 minutes later, I can see how it's doing. That's
That's
In theory.
assuming
Everything
that's
looks the same.
assuming that like the only thing in between you and the performance is this identity resolution. That's usually not the case. You have like ad ranking that has to pick it up. You have all these sort of like different steps. Honestly, don't know how long it would take. I think it's like a day or so that you can start like seeing good performance based on the labels.
Great. Other questions? There's a question in the back there.
Yeah, I just had a question about like, I know you said most of your stuff is in development, but you mentioned Neo4j a few times. I'm very familiar with Neo4j, but I know there are some limitations with the way that Cypher works since it's a relatively new language. So is Neo4j the only application or like graph that you're exploring, or are you using other, RDF triple store type technologies right now in your environments?
We explored some other solutions too. I know, if I remember the name correctly, like for instance, Tiger was something that we looked into. And honestly, we haven't made a decision about which one we want to use. Yeah, I mean, it's still under exploration. And honestly, I'm not the person who does the exploration. I'm like mostly on the ML side. There's like an infra team that had to support this. So we work closely with them to figure out, okay, like what is the best solution. When you say Cypher, do you mean like the language to
Yeah.
interact with the?
Query language.
So I had some hesitation about having like a specific language for interacting with the GraphDB. That being said, after ChatGPT, I feel it's much simpler because you can probably ask ChatGPT about what is the language to interact with this sort of like GraphDB, and then maybe you get good answers. Like if you have GPT-4, probably good answer. So I'm less concerned now. But again, like we haven't made any decision about like which one we want to use, and yeah, I mean, we might start using something and then switch something. But that's a very good question.
Great. Last chance for questions. All right, let's thank our panelists, please. The last part of the event tonight is we have a reception outside, which gives everyone an opportunity to mix with other people and chat and ask questions. And I'd like to thank you all for coming tonight, and hopefully you enjoyed it as much as I do.